Hi, this is Scott Wilkinson, host of Home Theater Geeks. In episode 81, I chat with Paul Barton of PSB Speakers and Greg Stidsen of NAD Electronics about the new headphones and iPod dock that were introduced at CEDIA. So stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Home Theater Geeks is provided by Cachefly at CACHEFLY.com.
This is Home Theater Geeks with Scott Wilkinson, recorded September 26th, 2011. Episode 81, In and Out of Your Head. This episode of Home Theater Geeks is brought to you by Netflix. Watch thousands of TV episodes and movies on your PC, Mac, iPad, iPhone, or TV instantly. All streamed directly to you, saving you time, money, and hassle. For your free 30-day trial, go to netflix.com/twit. Hey there, Scott Wilkinson, online editor of HomeTheater.com. And my guest geeks this week are Paul Barton from PSB Speakers. Hey, Paul, how you doing?
Good.
And Greg Stidsen from NAD, the Director of Technology and Product Development there. Hey, Greg, welcome to the show.
Hi, Scott. Thank you.
You bet.
Nice to be here.
I'm happy to have both of you here. We got a lot of interesting things to cover. But before we get started, I wanted to make sure that those who are tuned into the live video stream at live.twit.tv or logged into the chat room at irc.twit.tv can post questions for Paul or Greg, and I will pass on as many as I can. I'm watching the chat room here, and there are bunches of people in there as we speak. So I wanted to have you guys on because PSB and NAD, which are both under the same umbrella company of Lenbrook Industries, had some very interesting things to show at CEDIA. And Paul, let's start with you. The headphones that you showed at the show were your first foray into headphones. You've been known for speakers for many, many years, and excellent ones. Already in the chat room, there are people who are saying, yeah, PSB speakers, price to performance ratio, very good, value, excellent, with which I totally agree. What led you to decide to get into headphones?
Well, headphones are a growing market, and they're also a bit of an acoustical challenge, which over the years I've been always looking forward to doing, any acoustical challenges. Mm-hmm. And as you may or may not know, PSB has been doing, and of course I do most of the development work, and do it at the National Research Council in Ottawa. And to just go back
that's a government research facility, is it not?
Yeah. NRC is a government-funded institution, you could call it, that employs about 1,000 PhDs in all of the sciences.
Wow.
And that goes everywhere from physics to biochemistry to anything to do with science. And the facility has about 65 buildings to employ all of these PhDs. And I've been fortunate enough to have a facility or part of this facility available for doing product development, and over the years to do loudspeakers. That's in conjunction with a listening room or a couple of listening rooms and anechoic chamber. As of late, with the growing phones, and certainly it's a topic I've always been intrigued by, having frequented the NRC for as many years as I have, something that has been going on there and could be considered to be somewhat of a benchmark for the ear and how the human ear works, was work done under the section head at the National Research Council of the Acoustics Division, whose name is Dr. Edgar Shaw. And if you go to the textbooks, you'll find that Dr. Edgar Shaw really sort of laid the groundwork for the external and the inner ear canal. That is mapping exactly what all the features on our pinna stand for, and that really is a sort of a banking of knowledge that I can pull from, and certainly can expand on based on the research that had already been done at the National Research Council. Just to give you an example.
Sure. Just FYI, the pinna, for those who don't know, is the outer part of the ear. It's the ear flap. It's what we see and what we often generally refer to when we say the ear.
Yeah, and there are reasons why it has the features that it does as we evolve in order for us to survive and hear things and delineate things in rooms. It really is kind of a lens that controls the frequency response in the three-dimensional field, so that we can actually help to better locate sounds using two ears and the shape of our ears and its frequency response as a function of where sounds are, either behind us, above us, below us. The characteristics of the ear help to model in the brain and be able to delineate much more information than you would expect. One analogy or one comparison I'd like to just mention about the hearing phenomena, which I think many people are aware of, but not really conscious of what's happening. There's an interesting ear. Anyone who has been able to listen to someone who's on a speakerphone at the other end of a phone line usually knows that they're on a speakerphone. And when asked, why do they know they're on a speakerphone, and the answer coming back is, well, you can hear the reverb in the room.
You can hear the effect of the room itself.
Yeah, the reflections in the room added to the direct sound coming from the person speaking. But if you were in that room and I asked you, could you hear those same sounds? When people reflect on that phenomena, they think, no, when I'm in the room, I don't hear those things. And I always ask them, well, why don't you hear those things? And I get a million different answers. The true answer is that we use our two ears in our brain to suppress the later sounds that come from the original sound in order for us to better understand in a noisy environment, sometimes called the cocktail effect, where you're in a crowd of people, and if you were making a recording of a conversation in a large environment where there are a lot of people, or like a restaurant, for example, there would be no way to understand what we hear or what is being said. But if you were in that room talking to that person in that noisy environment, you can understand everything they say. It's because of the brains and the ear and the directionality of the frequency response of the ear that allows for this. I don't want to expand on that much more, other than a lot of research was founded and fundamentally done at the National Research Council in Ottawa, and I've been able to pool on that and use this to develop headphones and earbuds, or do research on headphones and earbuds. And I gave a photo of KEMAR, which is the test equipment that we use to do headphone evaluations. Here you see a picture of KEMAR in the anechoic chamber at the National Research Council. In this particular experiment, I was just surveying the noise, how well the seal on a pair of earbuds would be in the dummy head. And what you see on this dummy head and torso is an ear which is textured very similar to a human ear. It's a model of the average human ear, whatever that is. And,
whatever that means, yeah.
And there's a microphone in the environment and a loudspeaker in front of the mannequin, where I'm trying to measure the outside sound versus the inside sound that appears at the eardrum. And at the eardrum of this torso, better known as KEMAR, are two microphones at the end of a simulated ear canal, so that I can actually do some valid measurements of different sealing materials that help seal the ear, and of course many other types of experiments. In fact, this KEMAR can be used to do binaural recordings as well, which are kind of interesting to listen to back on headphones.
Yeah, I've actually done some work on that, by the way, just as an aside. I myself have done some binaural recordings, and the effect is quite remarkable. I wish more people would do it, but really to get the full effect, you must listen on headphones. That's the one caveat that binaural recordings, you must understand about them.
Yeah, but the inverse is true as well. In order to appreciate the full sound stage of a recording or a musical event in a venue, if it was recorded on point source loudspeakers in a room, I think many people who listen to headphones maybe haven't noticed, but most commercial recordings that were done, and even recordings that were done with spaced omnis in a concert hall, when you put a pair of headphones on, a lot of the center image sounds are inside the head. They're not outside the head. And binaural recordings will take that perception of being inside the head of a conventional recording and move it outside the head. And that's the challenge. And Scott, you and I were talking briefly the other day when we were discussing this interview that many people are looking. Well, what were we talking about? I lost my train of thought.
Well, just I think you were aiming towards duplicating the experience of listening to speakers on headphones.
Yeah, and oh, that's what it was. We were talking about some of these algorithms that have been developed by companies such as Dolby. Mm-hmm. To do
that's right, to simulate surround sound or 3D sound from headphones.
And that's what happens. You can take a conventional signal and process it in such a way which includes what we call the head transfer function. And that is because our ears, one is on one side of the head and one is on the other side of the head, the nose and the shadowing that occurs on either side of the head because of the one ear being on one side, one ear being on the other, there is an actual transfer function of sounds coming from the left, and the frequency response of that sound from the left getting in the right ear is a well-known pattern that our brains learn. And if you incorporate those kinds of filters into a normal recording, it will actually take and transpose the phenomena so that those sounds now become outside the head. And that is exactly what these types of DSP processing do when you take a conventional recording. And a lot of these recordings are created with the head transfer function in simulations for video games where you get surround sound on two driver headphones. You don't need multi-channel sounds all around you. And what it's really doing is incorporating the head transfer function.
Now, Sandman in the chat room is asking, are you designing both in-ear and over-the-ear headphones? What we saw at CEDIA was over-the-ear.
Yeah, we're starting with over-the-ear, but I believe this whole product category has lots of room for growth in the PSB offerings. I won't want to promise. I won't want to promise any timeline, but once you're down this path, I think there's a lot of opportunities to really raise the bar and improve the art of headphone. And believe me, I've measured and surveyed and listened over the last couple of years an awful lot of headphones, and believe me, there's a lot of room for improvement.
And I want to hear specifically what those areas of improvement are. But before we do, Virgil asks a question going back to your comments about the cocktail party effect. How is it that people can zero in on one conversation in a room and block out everything else? That's more a function of attention and the brain, is it not?
Well, yeah. Like I said, we're able to take and listen to and focus in and process very small signals buried within other signals. And that's just basically a brain function. When you add the fact that we have two ears and we can take a sound which is, you know, these noise-canceling microphones, where if you talk into the side of it, half your sound goes in the back side of the driver and half or the microphone, and half your sound goes in the back side of the microphone, and that results in no sound. So that if you only speak into the one side of the microphone, it hears your voice. But if you have a sound that's far away, which means that the sound actually is entering the front of the microphone and the back of the microphone at the same time, because it's not positioned directionally, it kind of cancels. Well, our two ears and our brain take that to the highest processing level that is possible. And that is why we can delineate sounds in a very noisy environment. You'll find that if you block one ear in a cocktail environment, you will find it very difficult to understand a conversation when you only have the ability to use one ear.
Well, that's very interesting.
Yeah, when you're in a cocktail environment, a noisy environment, and you're trying to understand somebody talking, just put your finger in one ear and see what it's like.
Mm-hmm. Well, let's get back to what have you experienced as being the deficits of headphones up till now? And perhaps Virgil's question might be related to this, which is, don't around-the-ear headphones give you better sound than, I assume, earbuds?
Well, earbuds, and I think right now the challenge for earbuds is getting them inserted properly with a proper seal, in conjunction with being able to keep them in your ears for long enough that you can enjoy them. Because I find that once you get it inserted strongly and you get a good seal and the sound starts to really get to where it should be, you'll find that after 10, 15 minutes, they start to really kind of feel uncomfortable. Mm-hmm. And so certainly that's the challenge, and you can bet that PSB is working on that sort of thing. Over-the-ear headphones are a little less encumbersome when it comes to being uncomfortable, although some are quite heavy and maybe become fatiguing. I found that in the early days, headphones like the Cos Pro 4As, which were metal cases and liquid in the ear pads, were quite heavy, and after a while I found them to be quite uncomfortable on the top, where the band is on the top of my head. Well, in the headphones that you auditioned at CEDIA, Scott, I believe we've addressed a lot of those concerns. I was really impressed or happy to hear the kind of feedback we received on the headphones regarding this comfort level, and that was a real concern of mine with headphones, being able to wear them for long periods of time. I personally spend a lot of time on airplanes, and believe me, I've been able to wear these things for 10 to 12 hours straight and find them to be quite comfortable. I'd like to talk a little bit about some of the technology that's being used in these headphones.
Yes, please, absolutely.
I have a set here which I'll move the camera or move them up to the camera and show you. But there are... By
the way, your lighting has gone kind of dim. I don't know... It just sort of automatically happened. I don't know if your screen went dark or something there, but I'd love to be able to see and everyone be able to see these headphones.
Yeah, let me see what I can do here.
While you're doing that, oh, there you go. There you go. Thank you very much. You got it.
Yeah. I guess what I'd like to do is just maybe touch on a few... Let me get my...
Yes, absolutely. You did mention a few things. I will say this. At CEDIA, obviously people are only going to be wearing these things for a few minutes at a time, as I did and everybody I saw there did. But it's really important to know that they'll be comfortable on a long flight. I know that for example, when I fly so far, I've been using Bose noise-canceling headphones, and over the ear, not on the ear. And they're relatively comfortable, but at the end of a coast-to-coast flight, I'm glad to take them off. So I'm looking forward to trying yours and seeing if they improve that situation. But I know that there are other improvements that you've also made here in terms of sound quality and noise canceling, because these are noise-canceling headphones. We want to make sure everybody understands this.
Yeah, I'll just review some of the features that I've incorporated into these headphones. First of all, when you're on a flight, I think everyone who has Bose or whatever headphones that are noise canceling may be frustrated from time to time when they didn't remember to bring an extra set of batteries and they get halfway there and their headphones go dead. Well, these headphones, when you turn them off, will actually still work passively, which I thought
in other words, you can still hear the music.
Yeah, you can still listen to them. The active noise canceling doesn't work, but at least they still work.
Right, which in the case of the Bose and most others, they don't.
No, they stop. I've also included a 3-position switch. Of course, the one position is off. The middle position is just amplification for those audiophiles who are in a quiet environment and don't want to add any more processing than they necessarily need. And then if you push it all the way up, and you can actually have active the amplifier working and the noise canceling at the same time. And the noise canceling below 1,000 hertz is up to 18 dB. And that's achieved by using 4 microphones to give you the signal to noise or the noise canceling. One microphone in each earpiece is on the inside near the driver or the transducer, and another microphone is on the outside of the transducer.
Why would you need a microphone inside near the transducer? I assume inside the ear cup.
Because you want to measure or read the sound that's actually inside the ear. Like when you play a sound and if you just put the ear pads on and somebody talks to you outside and there's no music playing, some of the sound just comes in to the ear pad, and you want to be able to to know what that sound is so you can feed it back out of phase.
So you can cancel it essentially. Yeah,
that's right. Now, of course, I mentioned earlier that they were voiced to be flat, and one thing we did at the National Research Council in the late 80s, early 90s was form a company of a group of loudspeaker companies to do non-competitive research. And in that, we determined that there is, in fact, in terms of equalizing a room, there is, in fact, a phenomena which we all expect to hear, which we call room gain. And with a pair of headphones, unlike a pair of loudspeakers, when you put them in a room, a pair of loudspeakers that are supposedly flat or equal energy at all frequencies, tend to have what we call room gain. And it's partly a phenomena of the reinforcement that rooms give at low frequencies more than they do at higher frequencies, partly because of the absorption coefficients of carpet and drapes are more higher frequencies, whereas at low frequencies there's a lot more reflections, so that they tend to add up in the room. And all of this happening in the room causes what we call a boost in a low frequency. And when you put a set of headphones on that's playing a recording that was listened to and monitored in a room by the artists and the producers, you want to add a little bit of that room gain back into the frequency response of the headphone. And what we've incorporated into this design is about a plus 3 dB per octave boost from about the 200 hertz region down to about 50 hertz, which is what I would consider to be a mild amount of room gain that you would expect in a good sounding room. So that's been sort of considered in the design of the headphones.
So this is one way in which you have created the illusion of listening in a room to speakers, not to headphones that are sitting on your head.
That's right. And if I were to set up an equalization system with a pair of loudspeakers in a room and I make them flat, most of the listeners would complain that there's not enough bass, because they're expecting to hear the speakers, including the room gain that you would expect to hear in a typical loudspeaker. When you think about a direct radiator in a recording studio, very often the direct sound versus the reflected sound at low frequencies, the output is omnidirectional, or at higher frequencies it's more directional, so that you hear a bit of what we call the sound power in conjunction with the direct sound of the loudspeaker. And that results in a slight tilt in the frequency response to be more at the low frequency than at the high frequency. And this is what we call the room gain. And I thought I'd put a little bit of that back into the sound of the headphone.
Mm-hmm. Now, Soundwave in the chat room asks, if the inside mic gets audio from within the ear pad, isn't that already in the ear as well?
Well, it's hard to in such
Isn't
a
it
short
too late then, essentially?
No. It's all a closed loop system. It's a feedback system. So one of the challenges in getting a high amounts of gain in a feedback system is that the system can go in phase and become unstable. That's the same thing as what happens when you take a microphone and shove it in front of a loudspeaker in a PA system. It starts
to get feedback.
Yeah, and that's because that's positive feedback. And what we need to do inside the earbud is to have negative feedback. And that's all to do with filters and phase and just doing the right ratio of the outside microphone with the inside microphone. And it would be too time consuming to break that into its components and explain it on this particular program. Maybe what I should do is on our website at some point describe in more detail exactly how this approach works.
Mm-hmm. I think that would be great.
It might be a nice white paper to do.
Sure. Mixer in the chat room asks, how much gain do we need in headphones at the lower frequencies?
Oh, I think I just mentioned to you a minute ago that it would be about a 3 dB per octave.
Oh, that's right. You did say that. Mm-hmm.
From 200 hertz down to 50 hertz. So it's just like a little bit of a shelf. From 200, it rises up 3 dB. So it's 3 dB up at 100, and it's another 3 dB up at 50 hertz, and then it sort of levels out.
Mm-hmm. Any other technological innovations that you put in these headphones?
Something I have the headphones here. I hope everyone can see.
There they are. Move them back a little bit so we get an overall view. No, backwards. Towards you.
Like this?
There you go. Yeah, there you go.
And
they are very comfortable. I will say that. I wore them at the show for a little while, and they are very comfortable, and they really sound great. I'm not trying to be an ad here, but all I'm doing is telling you what I heard.
And it has 3 indicators on here. In the off position, it'll be red in the powered position. I don't know if you can see red there. And then in the top position, it turns green, and that means there's active noise canceling and amplification.
Mm-hmm.
Something else that I did was make the ear pad oval, because believe it or not, let's see if I can show this here. Yeah, there you go.
The ear pad is definitely oval. There you go.
Okay. So you can see that it's oval, and it's actually thicker on this side and thicker this way than it is here, because this goes to the back of the head. And that makes it much more comfortable because your head slopes back. So it's thicker here, and this part here is thinner. And it's oval because I don't know anybody who has a round ear.
True enough. True enough.
And I think these would even fit Spock.
Right. Okay. Very good. Very good. So all you Vulcans out there, know that these headphones will fit you. Well,
That's right.
Icon asks the $ question. How much?
They will retail for $400 a pair, but they're fully accessorized. It comes with another feature built into it, which is a switch. Two power modules or 2 switch modules. One is capable of answering the phone with a microphone in it, and you'll be able to, so you can use this with your smartphone. You can advance songs or you can pause a song by pushing it once. You can advance the song by pushing it twice. You can go to the previous song by pushing it 3 times. And when you're on the airplane and the stewardess comes up to you and you want to hear what she's asking you, or how much cream you want in your coffee, you push this button, it mutes the music, and you can actually hear what she's saying. So you have like a monitor button.
Well, I have to say that because of all the time you've spent on airplanes, and I know you spend a lot of time. In fact, the last trip you took actually took you clear around the world.
Yeah, that was fun.
which was amazing. That's just amazing to me. But you spent obviously so much time on airplanes that it must have given you tremendous insight into what travelers really need in their noise-canceling headphones. And I think the result is pretty obviously an improvement from what I've seen, certainly, to anything else that's out there.
I wouldn't say it's revolutionary, but I'd like to think that I've considered all of the evolutionary things that take it to the next level.
Sure, sure. Well,
that really covers everything on the headphones, and I think now Greg can shine his light on some of the projects he's been working on, and I'd love to support some of the technical attributes of this wonderful product that Greg has to show. And actually,
yes.
I have a version of it here. Which
you're going to show it to us for sure.
Yeah.
And now that I'd like to get Greg in on the conversation, but before I do that, I think this is an excellent moment to take a moment and thank our sponsor for this episode of Home Theater Geeks, which is Netflix. Now, of course, most of our viewers know Netflix. It streams thousands of TV episodes and movies directly to you instantly, saving you time, money, and hassle. You can stream it from just about any device you have in your house: Blu-ray players, TVs, your computer, of course, gaming consoles, even your iPad or iPhone or various smartphones. Some Android phones, anyway. And if you have a gaming console, you can watch it right there as well. Apple TV, Roku. There's just a ton of different ways to get this streaming into your home. And you can watch these movies or TV shows instantly using any of these devices. You can even begin watching on one device and finish watching on another. Whichever way you choose to use Netflix, you can watch as many movies and TV shows as you want, anytime you want. And you can cancel any time, so there's really very little risk here involved. We have a free offer, a special offer for our listeners and viewers. You can try Netflix today for 30 days free by going to netflix.com/twit. Be sure to use this URL when you sign up for your free trial, netflix.com/twit. And we sure thank Netflix for their support of Twit and Home Theater Geeks. So, Greg, let's talk with you for a bit. You've been patient there while Paul has gone through some of the new technologies, evolutionary technologies in the headphones. And he also participated, though, in the development of a product coming from NAD, which was also very impressive at CEDIA. I heard it, and I was quite impressed by it. Why don't you tell us a little bit about your announcement in this regard there at the show?
Yeah, we introduced a product we are calling VISO One, and we're calling it VISO because it's a bit different from what NAD has done in the past. We're known for our stereo components and also our home theater components, but always in a traditional 43.5 millimeter form factor. With the VISO One, we're addressing a different customer, I think. I hope it's some of our same customers as well. But with VISO, we're going to be producing all-in-one systems. These are complete plug-and-play systems without all of the flexibility and that's available in a component system. But of course,
so this is a thing. This is a all-in-one thing. It has speakers. It's really basically an iPod dock with speakers, right?
It's a speaker dock. It's also wireless, so you can either dock your iPod or you can go wireless. We're using aptX Bluetooth. That's a new Bluetooth that's lossless, so there's no compression.
Really? Yeah. Oh, I don't think I knew about that.
Yeah, it's something that's been out for about a year now, I think, and it's included on some Apple computers. They just made an announcement that Nokia will be including it in their phones. I believe Samsung has also signed up. So it's a higher fidelity Bluetooth. And of course,
what's the bit rate? Do you know?
I don't know off the top of my head. I'd have to find that out for you.
Just curious.
Yeah. It's but unlike going through a network with AirPlay or something like that, or Delina streaming, this is just point-to-point. It instantly connects to any kind of handheld smartphone, including Apple and iPad. But it's very easy to connect, and the sound quality is superb.
Well, certainly what I heard on the showroom floor, on the show floor, I should say, not the showroom floor. It wasn't a retail establishment. It was a big, giant conference, a big, giant convention hall. And it really did impress me. Now, I know, Paul, you worked on the acoustics of this product some. Why don't you tell us a little bit about that?
Well, yes, I designed a system which was more optimized for a small loudspeaker using a very solid magnetic structure on a 5¼ long throw woofer. Many of the roots of which were based in some really good Danish loudspeaker technology. A very good friend of mine, who I've known for many, many years, collaborated with us on this, as well as the full-range drivers, which were, had to be capable of a wide range of frequency response and also cover right up to 20 kilohertz in a simple package. And what we ended up using...
One driver covers the entire frequency range? You're using true full-range drivers here?
Well, I'm using a full-range driver that goes from 500 hertz up to 20 kilohertz. And that's for left and right channel. And then a common woofer with summed low frequency, which means this unit has 3 amplifiers in it.
This was one question in the chat room. Mixer asks, are these systems with discrete amps or one in a chip?
No, well, it's a chip. And I'm going to get Greg to really talk a little bit about the pedigree and the legacy of this particular technology when it comes to the amplifier side. But let me just finish the acoustic side, and that is it's a bass reflex enclosure, so it has a port on the side of the unit. And I'm just going to take my camera and actually show you the unit.
Okay. Don't get dizzy now. As I recall, it's a kind of a big barrel-looking thing.
Yeah.
There you go.
So there it is, and the iPod, as you can see, is in the cradle right now. And around this side is the power switch, and then an indicator light down at the bottom. And then on this side is the port tube. You see it there. So
the bass reflex, as I recall, bass reflex does let you go lower with a given driver size, correct?
Yes, and if you do it properly, you can actually get a small driver to produce low frequencies which are uncommon for a given driver size and box size, because if you tune it, and this particular system is tuned at 45 hertz, you can actually, where the excursion of the woofer would be exceedingly large in a sealed box, if you tune it down and then cut the frequency below the tuning as quickly as possible, the system can handle quite a bit of power and give a huge amount of output for a given signal, because most of the work at its lowest frequency that it produces is coming out of the port. The driver is hardly moving at all. So this was just a way of, and it's a common approach, but an optimized bass reflex system. And I want to let Greg talk a little bit about the technological side, because with all of the technology that's embedded into the electronics that are in this system, gives the speaker designer like me degrees of freedom which I don't normally have when I'm designing normal loudspeakers. So Greg...
because you don't know what amp it's going to be connected to.
Yeah, and I don't have any control over that.
Right, exactly. So this is actually a dream come true for a speaker designer, in that you know what the whole system is going to be doing. Like many powered or active speakers, which is one reason I actually like that idea. So, Greg, yeah, by all means, do tell us something of the electronics that are going on in here. A mixer in the chat room asks, for example, are the amps Class D?
They are Class D, but they are also digital. So this is really a DAC that directly drives a loudspeaker. And it's quite a remarkable DAC because it's 35-bit, 844 kilohertz. It's far beyond the normal DACs that you see in most applications.
No kidding. Now, the digital audio,
architecture.
The digital audio coming off the iPad is nowhere near that much resolution.
Right. And so what we do with the extra headroom that the 35 bits gives us is we can do a volume control that doesn't truncate any bits. So it's essentially a perfect volume control. Mm-hmm. And it gives enough biquads to create filters. And that's what Paul has done on the acoustic side, is he can precisely match the amplifier to the loudspeaker. The other thing that's unique about this amplifier technology, and by the way, we introduced this 2 years ago in an amplifier called the M2, which is a $6,000 power amplifier.
$6,000.
So this is using that same technology that we used in a $6,000 power amplifier. Mm-hmm. And we've now put it on a chip so that we've dropped the cost way down for the actual processing technology. And then, of course, in this case, we don't have anywhere near the amount of power output that we do in the Master Series amplifier. But
sure,
by integrating it with the speakers, Paul is able to put the two together to get a very high acoustic output with extremely low distortion. This amplifier measures at 0.005% THD. It's extremely low in distortion, extremely low in noise. And the filters allow Paul to do the crossover in digital domain, the contouring he mentioned in the bass with the cutoff. You can do essentially brick wall filters and get much more optimization out of the acoustic design because the amplifier is part of that relationship.
Now, don't brick wall filters, though, give you phase anomalies that you have to overcome?
Not if done in digital domain, no.
Ah, no, okay, sure.
You can control both those parameters independent of each other.
I made a point, I had a thought earlier a moment ago when you were mentioning how this technology first started in the M2 amplifier, which is a very expensive, relatively expensive product, and now it has come way down into basically an all-in-one iPod wireless streaming type device. This seems to be the way of digital electronics. Analog electronics, if you want high quality, it's always going to be expensive. But digital electronics allow you to start expensive, and you generally have to because of all the R&D costs. But then as you stamp out 1 million chips, it becomes very cheap. And I suspect this is why a lot of people are moving more and more towards digital audio electronics. Would do you agree?
Yes, I would. And in fact, one of the unique things about this technology is that it has error correction, which other Class D amplifiers and digital amplifiers especially do not have. So we can compensate for the quality of output devices, for example, and get a much higher quality using less expensive parts than we would use in a very high-end amplifier. Mm-hmm. In fact, in this application, the loudspeaker itself is part of the output filter. There's no analog circuit anywhere inside the VISO 1. It's a pure digital device. We take the digital signal right out of the iPod. It doesn't go through the iPod's D to A converter or any of the limiting circuit in the iPod, and it stays digital right up till the loudspeaker. And the loudspeaker is actually part of the feedback and correction loop. So we can get very low distortion in actuality, not just on a piece of paper. And I think that's part of what you heard. It's remarkably clean sounding.
It really is. I have to say I agree. I guess the DAC, the digital to analog converter, though, there has to be one before the speaker anyway, and that's where you're talking about the 35-bit super high sampling rate DAC, right?
It's part of the processing. What we actually do, Scott, is we take the PCM, linear PCM from the source device, And that gets converted into pulse width modulation. So there's a process that happens there. And that has to be very accurate to get a good result. So we're clocking that with a 108 megahertz clock. So we can sample at a very, very high frequency. The amplifier is extremely fast. And that's part of the uniqueness of this technology, is just how fast it is. And the transient capability, if there was one thing that you said, well, what's the characteristic? What does it sound like? It just simply stops and starts faster than anything I've ever heard. It's very, very accurate on the transients.
Why do you have to convert from PCM, pulse code modulation, to PWM, pulse width modulation?
That's what drives the output devices. So the output sets are always switching at 844K, and then it's the duty cycle that determines whether they have, whether it outputs a signal or not.
And then the switching frequency then gets removed, or it gets changed from digital domain to analog domain by a simple LC network, a coil and a capacitor to ground at the output to get rid of the switching frequency. Hence,
but the switching frequency he said was like, what, 844 megahertz?
No, kilohertz.
Oh, kilohertz. Still, no one's going to hear that.
No, but that's why you only need a simple filter to get rid of its switching frequency, because it's so high above the audible range that it filters it out very slowly, but it's gone sufficiently enough because of its distance. Its bandwidth is away from the highest frequency that the system needs to produce.
Right. Okay. I got it.
Otherwise, you have to use these exotic high-order filters that cause phase distortion and all kinds of problems. If you can switch it high enough in frequency and then roll it off gradually so that by the time it reaches the frequency you need to get rid of, that filter is sufficiently down in amplitude, or the output is down in amplitude at that frequency, and you end up having to disturb the actual analog signal as little as possible.
Well, certainly we're getting some interest in the chat room. Mixer says, what is the model of this amp player combo? I want to buy it now.
VISO 1, we call it.
VISO, V-I-S-O.
V-I-S-O, and numeral 1.
Does that stand for anything, or is that just a name?
It's basically just a name. We think it stands for vision and sound, if you want to think of it that way. It's okay. It's also an Italian word that means face, and for NAD, VISO is not a plain black box like our normal NAD products tend to be. It's a much more part of the VISO concept is to have a high level of style and industrial design as well.
So then, of course, the big question, as I asked about the headphones, how much?
It's $700, $699, I believe, is the price in the U.S.
So $700 for this thing that lets you stream music from your computer or other device by Bluetooth, plug in an iPod or iPhone, I assume, and play it right from there.
It also has an optical input, Scott.
Ah, okay.
It has an optical digital input. So if you want to put a squeeze box into the back or attach it to the output of your TV, you can do that as well.
Oh, okay. Very good.
Well, you can also use it. It has a component video out as well, which would allow you to extract video off of your iPod that's docked in there and feed it into a television set.
Component video?
Yes.
Yes.
Wow, that's impressive. Because that's a fairly high quality video connection. I'm surprised you didn't go with S-video or composite, but you could even do high def with that if you have high def on your device.
Yeah, and another thing, like if you wanted to configure this, you could actually put this under a television set, feed your Blu-ray player into it digitally, and feed the signal. Optical. Yeah, optically from your Blu-ray player into it, and then watch TV and use this as your sound system.
It doesn't have any simulated surround capabilities, does it?
No. It's the speakers. The speakers are kind of too close together to really start playing games with that. I mean, there could be processing done, and there are even if you were to use this with a computer, say, there are some things in computer software and the sound card software that you get that can actually simulate some of that, which I invite people to try. It's kind of fun.
Yeah, but as you say, if the speakers are so close together,
it's limited on what it can do.
It's limited, yeah, exactly. So at that kind of price point, you're sort of, and pardon me for introducing a competitor here, but you kind of are competing with the B&W Zeppelin. It even somewhat resembles it. It doesn't go out to a point as the Zeppelin does, but how are you expecting to compete with them? You're in the same ballpark price-wise. I don't know if exactly, but
yes, and you know, there are a couple of products in that category. There's a Bang & Olufsen product that's a little bit more money. There's a Bose product that's a little bit less, and they offer good performance. But we think we've got something that is a step beyond that, not only on the technology, but also the performance and the flexibility of the system. But it's definitely in that category of an all-in-one, simple to use, simple to operate, good sounding system. And this is a little bit unique because we're not a speaker company. We're a speaker company and an amplifier company, and we've worked together, and we think there's a synergy there that is definitely worth taking a look at.
Sure. Well, certainly because both your companies are under the same corporate umbrella, makes it a lot easier, I'm sure. And I think the opportunity for synergy here really is quite remarkable. The two companies, NAD being electronics and PSB being speakers, I bet you there's a lot more interesting collaboration where this came from.
Yeah, it's a marriage made in heaven.
Indeed. Mark from San Jose asks, can it play other lossless codecs such as FLAC?
Oh, that would depend on what you've got plugged into it. So if you're plugging a squeeze box into the back, that will decode the FLAC. It'll take anything that's on an iPod, any
codec,
on the iPod,
any codec that an iPod uses.
Yes, because the iPod actually is doing the decoding there. Another great opportunity is putting an Apple TV into the back of it. If we were speaking about video before. If you plug an Apple TV and you can get HDMI to the TV out of the Apple and get the sound into the VISO 1. That also gives you AirPlay as well.
Right. Wow, it's both of these product announcements at CEDIA I thought were quite remarkable. And well worth talking about. And Reverb Mike asks about Roku. I assume you could do the same thing with a Roku box.
Anything that has a digital optical output. As I said, yeah, there are no analog circuits anywhere in the box, so it won't take an analog signal. It will only take a digital signal. Right.
Well, as I said, both these product announcements were quite remarkable, and I'm really glad to have both you guys on the show to talk about them and let our listeners know about them. And I myself will look forward to checking these products out in the near future. So thanks both very much, Paul Barton and Greg Stidsen of PSB and NAD, respectively. Thanks both, you guys.
I just want to mention one little thing.
Scott.
Oh, sure. Okay.
And that's their availability.
Oh, of course. Silly me.
And the headphones are going to be in limited quantity before the Christmas season. And Greg, I guess you know more about the VISO 1.
Yeah, VISO 1's in production now. We're about 6 weeks from it being in the shops.
There you go. Okay, so Mixer in the chat room. You got about 6 weeks to wait, and it will be available for purchase. All right, thanks, you guys.
Thank you.
Bye-bye.
So, of course, you can find out more about PSB at psbspeakers.com and NAD at nadelectronics.com. My online home now, I have but one. It is hometheater.com. You can also email me with questions or suggestions for podcast guests or anything you want to talk about to scott@twit.tv. And you can also follow me on Twitter at htgeekscott. Next week, Home Theater Geeks is going to take a break as I take care of some family matters. But 2 weeks from today, my guest geek is scheduled to be Derek Smith from SpectraCal to talk about TV calibration and a new video color processor that I saw at CEDIA that was very impressive. It compensates for different amounts of ambient room lighting in a very interesting and novel way. So I'm really looking forward to that conversation, and I sure hope you'll join me. Until then, geek out.